This assignment 3.4 is going to give us a review of average velocity, and we're also going to see again how to do regression equations using your TI-89. Okay, so first we have a lot of data points for a vertical motion problem. So we need to first enter all of the data into the list of our calculator, and then we'll be able to do a scatter plot, and that we'll just take what's on our calculator and transfer it into question number 1. So let me switch to my TI-89 emulator, and I'll just drag this over a little bit. Your calculator, when you go to when you turn on your calculator, your apps, your applications all show up on your home screen. This is an old version, so I'm going to use the apps button to get a list of all of the applications. So you want to find the data matrix editor, and you can find that as an icon on the home screen, or you can go to the apps button and then choose number 6 to enter data. And then notice we get this side pop-up if we want to just change what's currently in our editor, or if we want to do a new set of data. And the only difference is whether you want to keep the new, you're going to be asked to enter a name. So if you want to keep the old and create new, otherwise, once you're done with data, you could just keep it and type over the top of it. So let's do new this first time through. The type of data, and actually for the purpose of this problem, a couple choices would work, but let's enter this as a list. We're going to put our x's as a list and our y coordinates as a list. And then for the folder, we can always just leave that in the main folder. You can create storage folders on your calculator, but I don't think we use that option often enough, so we probably just keep it in the main folder. And here's where we have to give a name to this set of data. And this is going to default to alpha, so I don't need to hit the alpha key. So choose some variable name. You can give it an entire word or just a letter. So I'm going to, for no special reason, except that I know I haven't used it for any other purpose, I hit the letter W is going to be the name of this data set. So it's just to give it a variable name to save it. And you'll see how that works in a minute. So now we're going to hit enter, and a second time then to save it. And this is your data editor. So now we've got a long process, especially for this problem since there are a lot of data points. So in my C1 list, I'm going to put the x coordinate. So I'm going to put 0 from our chart of data is where I'm getting that. And I'm going to hit enter, and it will move down. So then I'm going to put in 0.4, our second x coordinate, and hit enter. And then 0.8. and so on, and I'm going to go all the way down the list putting in all of the x coordinates, but I'm going to turn off the video to do that. So I'm going to scroll over and go up to the top here to show you that the second thing then is in the C2 column, you're going to put the y coordinates and make sure you line them up so our first point has to stay 0, 0 across from each other, and the y coordinate of our second point, when x was 0.4, y is 18.2. And then when you hit enter, you'll enter vertically, and then 34.4. And of course, you're going to repeat this. So I'm going to pause the video and put in all of the data. And you can do the same. We've got quite a few data points to get in our list. And then I'll come back and restart the video to move on to the next step. Okay, I'm sure you're glad I picked a problem that had 20 data points. Make sure that you have the x and the y coordinates correctly matching across from each other. And now we're ready to see how do we enter this as a scatter plot. And we've already seen this in class once, but to refresh your memory, we need to decide how we're going to plot the data. So if you look, you can see plot setup is our F2 choice, and you can have several different plots at once. So you might have data in column C1, C2, C3, C4. So you notice that just like your Y editor, you can have a number of statistical data plots set up here. All right, so we're going to define the first plot. So I'm going to choose F1. And we've got several choices of how we want to plot this, and I'll just use the right arrow to remind you. But scatter plot is the first choice, and that's what I want to do. So we'll just keep scatter plot. And what type of mark do you want? A box is perfectly fine. But again, you can right arrow if you want to change to get a different type of mark. But a rectangular box works out just fine, so we'll leave that as well. But now we have to say where are our x coordinates found and where are our y coordinates found. And that, of course, was in column C1 and C2. So I believe that we're going to be in alpha mode right now, so I think it defaults to alpha mode. So if I just hit the key that has C above it, but then if I just type the number 1, that's going to give me the letter Q. So I want to get out of alpha mode to type 1. So C1 is where my x coordinates are. And let's go down and say that's C2. And now I think we have to hit the alpha key to get back to getting the letter C. And then 2. That's really, I think, the only things we need to set up here. So I'm going to hit enter for a yes, and then enter to save. And now you can see that it shows you that we're doing a scatter plot. The rectangular box there is what our marks are going to look like. It tells us our x variables are in column C1 and our y variables are in C2. So this is helpful if you have a lot of different plots set up. And notice that if you made a mistake that you can go and change those. And notice F4, the check mark, just like in your Y editor. If you have 9 different plots set up, you might only want to be graphing one at a time. So the F4 to select them. All right, if we go if we just hit enter, we've set up our data plot. If we go to the window setup then next, you could look at your data chart and say, well, what's the range for or what's the domain for the x's? That was something like 0 to 7 seconds. And what is the range for the y's? You could find your maximum height and go from 0 to, say, 90 feet. So you could set up your own window, and I highly recommend that. But to show you another feature, under the zoom, under F2 when you're in the window menu, if we go to F2 for zoom, a feature that you might not have used before is zoom data, choice number 9, and that tells the calculator you can figure out a window so that all of my data points will fit in. So let's do zoom data, but you could have also designed your own window. Oh, and I can see right here that I think I have an outlier. So I suspect I'm going to go back and look at my data list because I don't think, so that was a good choice. I think I can see that this scatter plot is my error. So I'm going to pause the video and go back and check my data because I think this should look more like a parabola for a vertical motion problem. So I'm going to pause and go look for my error, and I'll be back with you in a second. Okay, so indeed the y-coordinate of 84.2 I had entered as 842. It missed the decimal point. So now that I've got that fixed, now let me go to our zoom again and do a new zoom 9 for zoom data. And now I've fixed my outliers. And now I've got my scatter plot here, and it certainly looks exactly what we would expect for a vertical motion problem. It certainly looks like a parabola, but of course it's not given in the form of the equation. So before we find our regression equation on our worksheet, we can do our rough sketch of the scatter plot. And I'm just going to transfer here when I start writing. My windows are going to change, so you do not have to label all of these points. So let's just do a rough sketch here, and it's exactly, I think, what you would expect. So your points here, you get the idea that they might not be perfect, but our scatter plot certainly looked parabolic as we expected. So you might do a better job of that than I did here. Just says a rough graph, though. We're not going to take the time to label it. We've got that in our calculator. Okay, now before we do our regression equation, we're asked to do some other work with these values. So first we're going to find some average velocities. So what I want to do for part A is I want to take the height of the object at time 2.4 minus the height at 1.6 and divide by our elapsed time. And you can go back to your table then and get the x coordinates at 2.4. So 78.3 and 1.6 at 60.4. 78.3 and 60.4. And we can do this work with our calculator. So I'm going to pause and enter that, and then I'll be back to you with an answer. And I notice this is when the object is still rising in our units, so we'd have an average velocity. If my arithmetic, or if I've entered correctly in the calculator, 22.375, make sure you label the units, feet per second. And now we're going to do the same process for two intervals intervals, and then you'll see why we chose these intervals. And notice in the denominator here, you could right away put 0.4, and then for C, we're going to do the height at 2 seconds minus the height at 1.6 seconds. So for both B and C, notice that your denominators could be 0.4. So I'm going to get those values from the table up above, and I'm going to calculate them. So again, I'm going to pause to do those calculations. All right, when I paused, I think I noticed I had perhaps written this number wrong, h of 2.4 minus h of 2 seconds. So here's the data points we wanted to plug in, and here are my results. And now if you look, why would I have asked you to do these three particular average velocities? Because they are symmetrically, this one is to the right of 2 seconds, and this interval in C is to the left of 2 seconds. So if you averaged answer B and C, if you took the average of answers B and C, would you get the answer from part A? So that was the idea of specifically asking you about those. So now look how we're going to use that in question 3. Using your answers, what is the best estimate? The best estimate of the velocity at time 2 seconds. So perhaps if you had done the interval to the left of 2 seconds in part B, this is the left interval. And if you had used the interval, oops, do I have those backwards? That's the interval to the right of 2 seconds, a little bit after. And this is the interval to the left before 2 seconds. So would you choose one of those answers, or would you choose the answer that is symmetrically surrounding them? So I think that I would choose the answer for 2A as the best estimate of the velocity because it is the average of a symmetrical interval surrounding 2 seconds. And that might be, so we might want to say it's average velocity, I guess. I should be more specific. All right, let's see then what we're ready to do then to go back to our data and to our calculators. There was a reason we did all of that data plotting. Now our calculator will very quickly come up with a quadratic regression formula that best fits those data points. And it won't fit it perfectly, but it's going to give us the best quadratic equation to represent the data. So let me bring back the calculator here, and let's go back to the graph to remind you that that was our scatter plot. And now what we want to do is go back to our data. So you guys can go to your home screen again to get there, or you can use your apps menu. Let's go back to our data, and this time let's use current. So let's go back and see this was the data that gave us that scatter plot. And now to come up with a regression equation, and your TI-89 is so much easier than your previous calculator. So now we want to choose F5 and look at our options for calculating from data. And we can calculate, if I choose the right arrow here, we can calculate all sorts of regression equations. Well, we could see that this looked best as a parabola, and knowing it's a vertical motion problem, we have experience knowing that we expect that gravity problem to be a quadratic. So these are in alphabetical order, so you're going to have to scroll down to get to quadratic. Make sure you don't pick quartic. Make sure you pick quadratic regression. So go to choice 9 and hit enter. And then it's going to ask us some questions. So it gives us a right arrow. Then again, are we sure we wanted quadratic? That right arrow would take us back to our options. And then we're going to go down. The next question is asking us where can we find the x coordinates. We've done this already. Our x coordinates are in C1, and our y coordinates are in C2. And the next step, do we want our TI-89, as soon as it computes the regression equation, do we want to store it in our Y editor? And this is a really helpful feature. So let's do the right arrow and whatever you have open. I have Y1 of X open right now, so I'll put it there, but you could store it anywhere. And the frequency and categories, you guys in statistics might be more interested. We're not going to discuss that today. So we'll just leave these and go on to hitting enter to save. And as soon as it does its calculation, this might be small in this screen, but notice it gives you your general quadratic. Y is equal to ax squared plus bx plus c. And here it's telling us this is the coefficient for A, the coefficient for B, the coefficient for C. R squared tells us the correlation, how closely were the points correlated. And you might remember from doing some line of best fits that the closer you are to 1, the better fit you had. And our data fits very, very nicely. So we didn't have too many outliers at all. Okay, but we don't have to write this down here. It is also stored in our Y editor. So I'm going to hit OK. I might actually want to copy it from there next time, but let's go to our Y editor and notice that there is our equation. This triangle tells us it doesn't all fit, so we're going to have to scroll. And you don't have to copy it this carefully. You only need to have 3 decimal places of accuracy. So our A in front of our x squared is going to be negative 6.301. Nope. Let me round that correctly. Yep, that would be right. Negative 6.301. And I'm going to use the right arrow. And our coordinate, our coefficient B in front of the x, we would write 47.418, and our coefficient or constant C 0.508. All right, so I'm going to pause the video and then I'll write that on our worksheet for answer 4. But before I pause, let's go look at the graph so that you believe this is the regression equation. And you can see, in fact, what a great fit. Our data was collected very carefully here. So our quadratic regression equation fits very well. All right, so now let's take the time. You can go back to your Y editor and transfer that equation into your answer for number 4. I'll pause while I do that. Okay, so notice I wrote that as a height at time t. So if you wrote it as an f of x function, there's nothing wrong with that, whatever you call your variables. And I rounded the coefficients to 3 decimal places. All right, now that we have our regression function as y1, now we can go to the home screen. So to compute the instantaneous velocity of the projectile, well, now we can find out what h prime of t is. And we could do that with our calculator. So in the home screen, I can find the derivative. And I want to do the derivative of y1 of x with respect to x. And that in the home screen will give us the derivative equation. And then you could copy and paste that into, that derivative into y2 of x. Or your other option in the Y editor is to enter this into your Y editor, but then you wouldn't see the formula. So you've got 2 different choices. So I don't really need to see the equation necessarily, except I might find that easier to do question 6. So I am going to do this method. So then after I find the equation, by the way, as long as I'm writing here, then y2 is going to be my velocity function. So y1 is the height function. Remember, y1 is our height function, so velocity function is going to be in y2. So then in the home screen, I can just do y2 of 2 to come up with my answer. And of course, then I'll round it to 3 decimal places. So let's see if I switch back to the calculator here. So notice that y1 is our height function. I'm going to go to the home screen and let me clear so you can see this. Remember that our derivative operator is shift 8, so the second key 8 to get derivative, or you can get it from the table. We want the derivative of function y1 of x, and the derivative, comma, with respect to x. That's easy to forget that. Derivative of y1 with respect to x. And then I can arrow up to get that derivative, and I'll do green diamond copy. And then I can go to our Y editor. And in Y2, I can do green diamond paste. And when I hit enter, now I have the velocity function. So y2 is the derivative of y1. So now I'm going to go to the home screen and I'm going to use that velocity function. So now I want to know what is y2, the velocity function, at 2 seconds. What is the instantaneous velocity of, and I'm not sure I got y2 there. Let me see what I've got here. Is that a y2 of 2? All right. And we come up with 22.214. Now remember that that's what we approximated from the data table. So 22.214. 22.214, it's a velocity, feet per second. So this is from the derivative, so this is using h prime of 2. H prime of 2, in other words, is what we just did, 2.14 feet per second. That's a bad decimal point there. Let me just try erasing the whole thing here. And let me just scroll back to remind you that we had done that. And we had come up with using the average velocity. Using the average velocity, we had come up with 22.375. So once we have a regression equation and we do the derivative of height is the velocity. All right, a couple more questions here. Sorry, this is getting to be a long video. What is the maximum height the projectile will reach? Explain your method. Well, we think about this. If this is our height function, what do we know is an easy way to find the maximum? Well, we can use the maximum button on our calculator, but you won't always have that available. So you would say when the derivative, when h prime, or in other words, the velocity changes from positive to negative, h of t has its maximum. And of course it's local, but we know it's a parabola, so its local is its only maximum. So we can do that method on our calculator. So let me go now to my y editor and let's uncheck the first height function, and let's just graph our second function, which is our velocity. And I think I should also turn off our plots. So let me go to plot 1 and just choose choice to uncheck that. So F4. It's still there, we're just not seeing it. Oh, and I didn't save my unchecking of 1. All right, so now we might not have the correct window that we need. Let's go to the graph. Remember that we're still set up for our stat plot. We want to know when does so now we're only graphing the velocity function. When does it change from positive to negative? So in other words, we can find this x-intercept. So we don't have to change windows. I think we can see this here. So we want to find out when the y-coordinate is 0. Well, we've got a choice, and there's lots of ways of doing this, of course, but under the math menu, we can find the 0 of this function. Remember that the 0 is the x-intercept. So we want to have a lower bound, and unfortunately it's kind of right behind the typing there. So I'm going to hit enter for lower bound, and then I'm going to go to the other side, and I think I'm on the other side, and hit enter. And it found our 0 at 3.763 seconds. At 3.763 seconds. All right, so let's record that on our paper. And we could go back up and check to see if our data matches with that at about 3.7 seconds. So here we get to a height of 90 at 3.6, and at 4 seconds it is lower. So it does appear that our vertex falls in between 3.6 and 4 seconds. So our answers are matching our data set. And I think we have one more thing to go here. Sketch the velocity of the projectile over the interval. Well, our velocity function, we know that the parabola, so the parabola is second power, so we know that our velocity function is linear when our height function is quadratic. And we just located this point right here, 3.763 seconds is where the parabola reaches its maximum. So it was where the first derivative changes from positive to negative. And that should do it.